So in order to find the optimal tree methods use cross-validation. This is something that we have discussed under classification trees. So we'll take a quick look at cross-validation in the context of regression trees. Okay, so of course in cross-validation, what the methods do is they take all the training data, right? Remember, in cross-validation, what we are trying to do is to find the optimal tree and avoid overfitting. So we take all the training data, and of course we know that the root node error for the training data in our example is 478,513.8 or 514. We divide that by 20, and that gives us what is called as a root node error of 23,926 per case, because there are 20 cases which are generating this amount of deviance. So this is basically the deviance per case, the average deviance. Okay, so what we do is we take all the training data and divide it into 10 parts. Okay, in cross-validation, you divide into a certain number of parts, and by default, it divides into 10 parts. Okay, and as we've discussed before, what the system is going to do is it's going to treat 9 of those parts. So for example, suppose there were 1,000 cases in the training partition, right? So it's going to divide it into 10 sets of 100 each. It's going to use these 900 initially to build a tree, and then it's going to use the remaining 10 to test the tree. Now this is outside of the test partition. The test partition is completely separate. Now, so within the training data, it's dividing the training data itself into training and test. Okay, so this is not the real test partition. The real test partition is outside. Okay, so this is just, you could think of it as a cross-validation test partition. Okay, so it's going to build the tree with these 900 and test the tree with the remaining 100, or this 90% and that 10%. Then having done that, it's going to gather some statistics. Then it's going to treat 1, 2, 3, 4, 5, 6, 7, 8, and 10 as the training to build a tree, and use 9 to test it, and so on and so on and so on. So obviously this process can be done 10 times, with each time with one of these 10 serving as test and the remaining 9 serving for building the tree, serving to build the tree. Okay, so this process goes on and we reach here. So there are 10 possible occasions when you can do this. Okay, now within each possible occasion, so for example, if you consider the tree with only one leaf, okay, that is just the root node alone, you're going to do that 10 times, right, for each of those cases, right? So when you consider trees of one leaf only, which is the root node alone, you have 10 trials because you're going to repeat it 10 times. And for each trial, you're going to get 10 error values. Okay, you're going to get 10 error values, and therefore you compute the mean. That is, you're going to get the overall error, overall deviance. That is, for every case with one leaf, you're going to make a prediction. And of course, you have the actual value. So you have the deviation between the predicted value and the actual value. You calculate the sum of squares, right? And then you calculate the mean of that, okay? Mean of the 10 error values for each of the 10 trials. So that is what is called as the cross-validation error. Then you have 10 values, you calculate the standard deviation. That is called the cross-validation standard deviation, XSTD, right? So you get X error, XSTD. Right? So again, what we did is, for each of these 10 times, you first consider the tree with only one leaf, right? That's the starting point, right? Of course, when you have a tree with only one leaf, you make a prediction from that tree with one leaf for the cases in the test part, right? In the 10% that you left out from this process, okay? So now for all the cases in that 10%, right? Let's say there are 100 cases there. For every case, your one leaf tree is going to make a prediction. And of course, you've got the actual value. So you've got the deviation of the prediction from the actual value, and you've got an error for every case, right? So for each of those 100 cases, you're going to find the squared deviation, add it all up, and divide it by 100. That is, take the average. So for the tree of one leaf, with this case, with the first 9 parts being training and the 10th part being the test, For that, you get one value of the deviation, right, of the mean error. You do that 10 times, so you get 10 error values. Okay, so for one leaf, you've got 10 error values. You find the mean and standard deviation of that. Okay, so do the same thing for 2 leaves. Okay, and so on and so on. So do it for all the 10 leaves. Okay, so the net result of cross-validation yields something like this, right? So tree size 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Of course, you could have more, right? If your data is large, you may not have just 10 leaf nodes. You could have 20, 50 leaf nodes. Okay, so this is going to be the error on all the data. And then this is the cross-validation error and the cross-validation standard deviation. Okay, so this is what is called as the CP table that the system generates. Okay, and of course, what you're looking for is the point where you've got the minimum cross-validation error. Remember, the cross-validation error was calculated on data which was not used to build the tree, right? Remember, as we did this whole process, see, notice when we built the tree with this, you used these 9 as training, and you used this should be 10. You use this as test, right? Now this part was not used to build the tree. This part is independent data, right? So all the cross-validation errors that you've got, all these cross-validation errors, these are from independent data, right? So ideally, what we are looking for is the tree corresponding to the minimum cross-validation error. Okay, so if you went by the minimum criterion, then you would actually select this tree because this has the minimum cross-validation error, right? In fact, in this particular case, the cross-validation error keeps on decreasing and you will select a tree with 10 leaves. But in practice, as we did with classification, you're going to use the one standard deviation rule. That is, you're going to take the minimum cross-validation error, find out its corresponding standard deviation, add it up, and choose the tree whose error is just less than that amount. Okay, so now this part I'm going to skip. This is explaining what these error values are. Okay, so basically we choose the tree with cross-validation error less than equal to the minimum cross-validation error plus the corresponding standard deviation, right? So it's, in this case, we are going to select that's the minimum cross-validation error. That's the corresponding standard deviation for the errors, right? So when you add it up, you get 0.187073, okay? And that tree is the one which has got slightly lower error than this, okay? So if you go to a tree with size 7, then the error is more than this, 0.180. The error is 1.194. This is the first tree whose error is less than this. So we are going to choose, in this case, using the one standard deviation rule, the tree with 8 leaves. Okay, so that's the tree which we'll choose using this condition. Okay, so we use this, and of course, we can do the same thing using the plot CP, right? So if you did plot CP, as we'll see later, you get this plot, and essentially what you do is you choose the first point which is below the line. This line is basically minimum standard cross-validation error plus the one standard deviation, right? So this line really corresponds to that. And we want to choose the leftmost point that is below the line. So in this case, again, it comes to 8.